Hello, welcome. We're starting R4 today. R4 is our factoring section. Factoring is very important. In order to do so many things later on, you have to have a good understanding of factoring. And each individual type of factoring is not that difficult to do. I think the hard thing about factoring is how do you approach it? What type of factoring do I need to do? So one of the things I like to do when I teach factoring is create the handy dandy guide to factoring, or my infamous handy dandy factoring guide. It's really cool. So what this has is you're going to make this table. It's going to take like a whole sheet of paper to do all the different types, and you're going to have 4 columns. The 4 columns are going to be the type of factoring, when to use that type of factoring, an example of that type of factoring, and a fun fact about that type of factoring. So the first type of factoring that we're going to take a look at is GCF. GCF. Now, GCF, it is the grandfather of all factoring. We can try to do GCF. Again, we can't always factor things, factor polynomials, but we can always try. So we can try to use GCF for any size polynomial of any degree. When we talk about size of the polynomial, we're talking about like if it's a trinomial, it has 3 terms, binomial 2 terms, polynomial more than 3 terms. So any size of any degree. The degree is the value of like the highest exponent. So if it's quadratic or x squared, it would be 2nd degree. But again, GCF, we can try for any size polynomial of any degree. So when we look for GCF, this is a trinomial here. We look at each term and you see if there's anything in common that we can factor out. So if we look at the coefficients of 10, -15, and -5, that allows us to factor out a 5. Okay? Now, if we look at the x's, okay, can we factor out any x's? Yeah, we can factor out, each of these 3 terms has at least one x. We have an x squared, an x, and an x. So we can only pull out one x. That would be the greatest amount of x. That's why it's called greatest common factor. And let's look at the y's. Let's see, we have a y cubed, and a y, so I can only pull out one y. All right, now, what's factoring's like dividing, right? You're dividing out factors or numbers and variables. So the coefficient 10 divided by 5, we're going to be left with 2 for our first coefficient. When I factor out an x from x squared, or x squared divided by x, we'll leave just an x there. And when I factor out this y, well, there's only one y, and that y was factored out, and so there's no y's left over. Minus, here I'm going to have 3xy squared, because 15 divided by 5 is 3. I pulled out the one and only x. I pulled out one of the y's, so I went from y cubed to y squared. Now, this one's interesting. Look, 5 divided by 5 is 1. X divided by x is 1. Y divided by y is 1. So really, when everything comes out, when the whole term comes out, we're left with just a 1. Now, you can check to see if you did it right with distributing. If I distributed this to here, I would get exactly what we started with. Because GCF, well, really all factoring is kind of the opposite of distributing. Factoring is like dividing, distributing is like multiplying, okay? And factoring is the greatest common factor would be the exact opposite as if I was to distribute this term on the outside to all 3 of those. Now, the fun fact about GCF, super important fun fact is, sometimes when you factor a polynomial, you have to use multiple types of factoring. Well, you always want to do GCF first. So anytime you're about to factor something, you always want to check and make sure to see if there's a GCF, and that might lead to another type of factoring. Okay, I've got the next type of factoring coming up in the next video, but we're going to add them all to this one handy dandy factoring guide.